All right, guys, let's review the basics on statistics. This is stuff that you would have learned in either middle school or Algebra 1. Mean, median, mode, standard deviation, that stuff. Box and whisker plots. That's basically a summary of what we're looking at right now. I'm going to go through as fast as I can. So if you're finding the mean, all right, these are all called measures of central tendency. Yep, already mentioned that. So of course, if you're finding the mean, you're just adding them up and dividing by how many items you had. So in this case, it should have been 1.7. All right, the median. That's that one where you line them up in order from least to greatest, and then you find the middle one. All right, so in this case, the median should have been 2. All right, I know I'm going fast because this is review for you guys, but if I go too fast, just stop me. Look, wait a minute, Burton, what's this again? I'll slow down for you. The mode. The mode is the one where it's the numbers that are repeated the most often. Okay, so in this case, the most common numbers are 0 and 2 because there's 2 zeros and 2 2s. What happens if nothing repeats? You just put no mode. All right, but in this case, we have 2 modes, 0 and 2. Did I hit pause? Later, I'll show you how to put this in your calculator. So in example 2, if we wanted the mean, again, you add them up and divide by how many you have. So everyone should have gotten 6.5 for that. The median. Put them in order from least to greatest. You're looking for the middle number. In this case, there is no middle number because you had an even number of elements. So you do the average of the middle two. So your two middle numbers are 6 and 8. If you added those up and divided by 2, you get 7. All right, so the median would be 7 in a problem like this. And then the mode. What am I about to say about the mode? None. All right, no items are repeated. Yeah, mode none. All right, let's remember about box and whisker plots. These were all about having your 5 key values, your maximum, your minimum, your median, and then your 2 quartiles, which is like the median of the lower half and the median of the upper half. You need your 5 key values. Again, on another example, I'm going to show you how to pull all these values off your calculator. But for now, let's sort of look at it by hand a little bit. Okay, oh yeah, this is none. So let's make a box and whisker plot for these values here for example 3. Okay, so it's all about finding our 5 key values. If you were going to do this by hand, you would really want to have your values in order from least to greatest so you can get the median and all that kind of stuff. So we have 3 of our key values right here already. The minimum, the maximum, and then our median is 7. Oh yeah. So all we need is the lower quartile and the upper quartile, Q1 and Q3. Okay, so Q1, that lower quartile, is going to be the median of the left side. Notice it doesn't count to 7. That median that we already had, that's not included when we do the 2 halves. So looking at these, you shouldn't even need a calculator for this, right? What's going to be the median between the 5 and the 6 here? Right, obviously that's going to be 5.5. And then on the right-hand side here, it would be between the 8 and the 9, so that's 8.5. So now we have our 5 key values, 4, 5.5, 7, 8.5, and 10. So those key values need to go on our little graph, if I can remember them. So remind me again, what was our lowest value? Wait, I need some numbers on here, don't I? Okay, so our lowest is 4, our highest is 10. Okay, so if, let's say these numbers were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should cover it. So our lowest value is here. No, that's a lie. What was our lowest value? 4? Our lowest value is here at 4. I'll put a bar there. What was our highest value? 10. So I'll put a bar there. Okay, and then we had our quartiles, Q1, Q2, and Q3. 5.5, 7, and 8.5. Okay, so here's 5.5, here's 7, and here's 8.5. So those 3 quartiles where I put those dots, that's where you make your box. All right, so I'm going to draw a rectangle using those 3 dots as a guide. All right, I'll draw a rectangle and I'll put a line in the middle where the median is. And then what they call the whiskers of the box and whisker plot is where I stretch these out to my high and low. So that's how you do a box and whisker plot. The interquartile range is the difference between the third quartile and the first quartile. So it should just be the 8.5 minus the 5.5, so that's going to be 3. Okay, I'm going to pause the video and walk around and see if you guys have already done example 4. All right, looking at example 4, make a box and whisker plot of this thing. Oh, you know what? I'd like to show you how to get these values off your calculator this time. So make sure you have yourself a TI-30 XS multi-view right now. Because everybody wants to do things the easy way, right? Okay. Yeah, make sure you have your TI-30 XS multi-view because a lot of this stuff you're going to want to do on your calculator. So you want to hit the data button, and here's where you can type in your data. So this is how we're going to do it this time through. Just so I don't have to switch back and forth, Destiny, will you get ready to read me these numbers? You can just read them to me right like they are on the paper. They don't have to be in order or anything.
Right.
Yeah, all right. 13, 14, 18, 13, 12, 17, 15, 12, 13, 19, 11, 14, another 14, 18, 22, and 23. Okay? So there should be, I have that there's 16 numbers. Is that right? All right, just in case I skipped one. So there should be 16 numbers. So just follow along. I hope everyone's doing this in your calculator the way I am. I want you to be able to do this. So to get the 5 key values off your calculator without having to write the numbers in order and all that stuff I was doing on the first problem, if you hit second data, so above the data button it says the word stat in green. That's for statistics. That's where you're going to get this information. So you want to hit second data, and we want one variable, statistics, which is the default. So just go ahead and hit enter on that. The way it is fine, so just hit enter a couple more times until you get to this screen. So this has a ton of valuable information on it, including stuff we'll need for later problems like standard deviation. The N right here at the beginning just is reminding me I had 16 numbers. But here come the values that I need. On another problem we'll need the X bar, which is the mean, but we don't need that on this problem. So skipping down. They give you the 5 key values all in a row. The minimum, the first quartile, the median, the third quartile, and the maximum. They just give you all 5 values that you need for your box and whisker plot all right in a row. Okay, so that's going to be super helpful. So we have 11, 13, 14. So I'm just going to plot this on my situation. Okay, I need to, all right. So probably if I start at 10, 11, 12, 13, 14, 16, 17, 18. Okay, so my minimum was what, 11? Okay, and what was the first quartile? 13. And the median?
14.
All right, the third quartile?
18.
And the maximum? 23. Okay, so those are my 5 key points that I was able to read those just straight off my calculator screen here. So of course, the box is going to be formed around the quartiles with a line at the median, and then I'll do the whiskers out to the max and min. Okay, so that's how you do that box and whisker plot with the assist of our TI-30XS multiview. All right, the interquartile range again is going to be the third quartile minus the first quartile. So 18 minus 13, so 5. Okay, I'm just going to click through that real quick. Yep, so all of that, that's what we got. Okay, now look at this. You know, can I make this bigger? Okay, so looking at these two data sets, 19, 20, 21, and then the 0, 20, and 40. They both have the same mean and median, but they are very different. What's so different about these two sets, even though they have the same mean and median? Why are they dramatically different, even though they have?
The first number is on the second one. It's a lot farther from the last number.
Yeah, looking at the red, which one of these data sets is more spread out?
The blue one.
The blue one is way more spread out. It goes from 0 to 40, whereas the red set, 19, 20, 21, the red set is very closely packed together. So we're talking about spread now. Spread often matters when you're dealing with data. So mean, median, mode, those values don't capture everything we need. We need other values to represent how closely spaced the data is or how spread out it is. So we just refer to it as spread. The most common ones that are used, well, they're probably going to list them out here. The most common ones that are used are range, interquartile range, variance, and standard deviation. So mostly we're going to wind up talking about range and standard deviation. Okay, from this screen, the main thing I want you to get are the symbols. Variance is sigma squared. That's a sigma, by the way. Kind of looks like an upside down Q or something. But variance is sigma squared. We'll talk about what that is in a second. Standard deviation is given by sigma. So just memorize the symbols and what they go with. Okay, these numbers reflect the spread. So a high standard deviation would mean the numbers are more spread out, like the blue set was. A low standard deviation would mean that the numbers are close together, like the red set was. Okay, it'll be easier for me just to show you the standard deviation. Trying to read standard deviation in words is hard to follow. All right, Destiny's going to read me the numbers for example 5. Go. 6, 8, 7, 5, 10, 6, 9, 8, and 4. All right, again, hit second, data, hit enter a few times until we get to this.
I didn't go to class and I'll figure it out.
All right, the first thing we need for the standard deviation is the mean. The mean is 7. It's the x bar. So that's the mean. So we have the mean is 7. Now, if we put this data on the chart here, so it would look like this. All right, so you've got this first column. Now in the middle column, you do the differences from the mean. So you're going to take each one of these values, and remember the mean over here is 7. So we're doing like 6 minus 7, 8 minus 7, 7 minus 7, and so on. Okay? So Libby, are you ready?
Yes.
So, okay, so give me the middle column.
Oh, it's not, it's in a different order.
-1,
1,
mm-hmm,
0,
0,
-2,
-2,
3,
3,
-1,
mm-hmm,
2,
got it,
1,
got it,
-3.
-3. Any questions on where those numbers are coming from? Just doing each value minus the mean. Now for the third column, we're supposed to square all these. So that's going to be +1, +1, 0, 4, 9, 1, 4, 1, and 9. Okay? Now for the variance, which remember the symbol for variance is sigma squared, the variance is the average of these. So if you were to add all of these up and divide by, how many numbers do we have here?
9.
Yeah, add all these up and divide by 9, and that's going to be your variance. Now I'm going to cheat and use my PowerPoint. Yeah, so we added all these up, we divided by 9, and no, that's just the mean. Hold on, we're not there yet. There we go, that's what I meant. Add all these up, divide by 9, you get 3.3. Okay, so I added all these up. Did it show what that was? No. So you get 3.3. So that's the variance, is the average of these squares. Now the standard deviation, the symbol for standard deviation tells you how you're going to find the standard deviation. So if we have sigma squared right now, and we want just sigma, how do we unsquare things? We use the square root. That's why sigma is going to be the square root of 3.3. All right, and that's 1.83. All right, and that seems like a good place to stop. I hope this video was helpful. Blow up that like button, y'all.